Here we have an interesting workbook. I've got a worksheet called Map. And in this map, I have 500 rows and 500 columns of data, each representing an elevation point on a map. So here I have point 1, 1, those are my x and y coordinates. This has an elevation of 18.26. If I go right one cell, this has an elevation of 41.7. And I use conditional formatting here just to kind of visually represent what that would look like. If I go back to the search worksheet, I can see here's a copy of that worksheet, just a picture of those cells that we can take a look at. So if I change my coordinates here to x being 2, y equaling 1, this elevation formula here in B5 is going to tell me the value of the cell on that map worksheet. So it's using a couple of functions that we haven't covered in class, but just know that's what it's doing. So the x and y are our inputs. The elevation is the output. That's the height on this topographical map right here. So our task here, we want to find the highest point on this map. So darker green values are our high points, the light yellow are the low points, and looking at these colors, it's really hard to determine what the highest point is. So we can use Solver to help us figure this out. And we're going to evaluate doing this with a couple of different methods. So I'm going to start at x1, y1 for each of these. And let's take a look. Make sure we go to File, Options. Make sure you have Solver. I'm going to go to Add-ins, Manage Excel Add-ins. Make sure we have the Solver add-in checked. All right, let's set this up. So we have some constraints. These coordinates, if I jump to the end of this row, the last value is 500. Control home to go back to the beginning. If I do end down, it takes me to the last row, 500 also. So my limit for the x and y coordinates should be 500. And it has to be integers. I can't have a reference of 1.5. There's just no value there between those columns. So they should be integers with a maximum of 500. So let's go to Solver. So I want to find the max because I'm looking for the highest value. So my objective is going to be this elevation in B5. And I'm going to change the x and y inputs. Now I've got a couple of constraints. I'm going to add the cell references to my x and y. They should be less than or equal to 500. So I'm going to click Add because I want to add another constraint right away. And those same cell references, I'm going to choose int, saying that they have to be integers. And I'm going to click OK. Clicking OK adds that constraint and brings me back here. Now the solving method, we're just going to go down the list. I'm going to choose GRG nonlinear. I'm going to look at options and GRG nonlinear. I don't want multi-start right now. So I want that unchecked. So I'm going to click OK. Now I'm going to click Solve, and let's see what happens. You'll just watch down on the bottom left-hand part of the screen where my mouse cursor is now. You'll see some calculations happen in Excel pretty quickly. Very quickly. Okay. This didn't work super well. So it finished. This told me, well, it didn't really do anything. 18.26. The solving method just was not a good fit for this spreadsheet. Okay, but how about if we use the same feature with multi-start? So instead of just starting up at the top left, multi-start will basically pick some random points inside this topographical map, and it will solve from there. So I'm going to click Solver. I'm going to go into my GRG nonlinear options, and I'm going to use multi-start, population size of 100. So it'll pick 100 random points. That's fine. I'm going to click OK. Now I'll click Solve, And you can see it's doing quite a bit more calculations now, so it's going through its algorithm. Okay, so this time it did better. It actually did something more interesting. Now, if you run this, these algorithms are non-deterministic. That means that your computer is generating random numbers to generate those random starting positions. So every time you run this, you might come up with a slightly different answer. Okay, so let's reset this to 1, 1, and let's try simplex LP this time. Solver method, simplex LP. Let's just look at the options. There's no specific options for simplex LP, so that's fine. So I'm going to go ahead and click solve here. And it doesn't work. This method just doesn't work with this type of data. No answer. Can't work. All right, so let's try evolutionary. So I'm going to go to solver, and I am going to choose evolutionary. Let's look at the options for evolutionary. This is kind of like simulating evolution. So you've got mutation rates. So think of one individual in a population has a gene mutation and it changes a little bit. So this mutation rate changes how much each of these values change. Population size, it's, you know, how many samples is it going to start with. So this is, I'm just going to go with these for now. I'm going to click OK. And I'm going to click solve, and it'll take some time. So you can see Excel is looking through, searching. So those 100 different spots inside the solution, what Excel is doing is it's moving them all around a little bit, up, down, left, right, just a little bit, seeing if the value goes up or down. So you can see the incumbent here, that's the best value it's found so far, and it's seeing if it can beat that value. So far it's trying a bunch of different solutions. It can't find any better value just yet, but it's looking, and it's looking hard. You can see that this takes a while. Can take a while, but this is extremely sophisticated analysis that it's doing. Oh, you can see it just bumped up. Now we've got 186.34. So we'll see. We'll let it run. If you're actually working with genetic algorithms, people have used genetic algorithms to design efficient plane wings, all sorts of use cases for genetic algorithms. You might have a supercomputer running a genetic algorithm for months. This won't take months. This problem space is just not that big, but it's doing pretty well. And should finish up fairly soon. I'll pause the video until it's done. Okay, that didn't take too much longer. Solver finished, and it says solver cannot improve the current solution. All constraints are satisfied. So I'll keep the solution. Okay, so x of 238, a y of 159 gives me a value of 189.22. Now let's cheat a little bit. Using solver is not the best way to find the answer in this problem, actually. If I just use the max function, Excel's pretty awesome at this. Okay, there's actually a slightly better value in there. I'd have a high of 220.46. So why did we not get that value? Well, it has to just do with the way Excel works and perhaps not starting in the right spot or just not stumbling across the correct, what would we call the correct solution, the absolute maximum, because of just some randomness in this process. An evolutionary algorithm is a search function, so it searches as efficiently as it can, but there's no guarantee that it's going to find the absolute optimal value. So comparing these methods, we can see that our evolutionary algorithm did the best. The GRG nonlinear with multi-start did better, but it seemed to get stuck in one spot, couldn't improve anymore. With multi-start, it did much better than the GRG nonlinear, and simplex LP simply wouldn't run. So depending on your data, depending on your use case, some of these algorithms will be better fits than others. Let's try this evolutionary algorithm again, just for giggles. Let's go to Options, Evolutionary. Let's change our mutation rate. Let's make it, instead of 7%, let's make it 20%. And what if we have a population size of 500? So I'm going to click Solve, and let's see what happens. And I'm going to pause the video so you don't have to watch it run. Okay, solver is still running, but you can see it found the value 220.46. So using a bigger population and a higher mutation rate, in this instance, found me a better solution. So we know it's running, it's going to work. It's not going to come up with a better value than that. So that's a little bit about the different methods, showing how you can try different methods depending on your problem, but depending on the problem, you should use proper judgment in determining which algorithm is going to be the best fit for your use case. All right, so I'm going to click OK. So this time evolutionary got us a better answer, 317, 136, 220.46. Now I'm guessing if I increase the population with GRG nonlinear, I would also get a better answer. Could potentially improve. Also by random chance, if I just ran this again, I might get a better answer, or I might get a worse answer. That's just kind of the way it goes here. All right, so these solving methods, very effective. Excel is extremely powerful.